Hello friends, welcome once again to HMNOF online math class. In this video, I'm going to use three different methods to solve these two problems we are having here. And this is a logarithm problem, so I'm going to utilize three methods to solve them. Now to do that, you need to know that when you have the logarithm of 3 to base of 27, that this can be seen as logarithm of 3 to base of 27 equal to x, because you don't know what it will give you, so you can equate it with x. Hence 27 power x is equal to 3. So 27 raised to the power of x is equal to 3. This is just the relationship between indices and the logarithm. And the 27 can be split into 3 to the power of 3. So we have 3 to the power of 3. Then you add your x equal to 3. This 3 can be seen as 3 power 1. Then, since the bases are the same thing, automatically the power should be the same thing. Therefore, 3x is equivalent to 1. Divide both sides by 3. When you do that, you see that x is equal to 1 over 3. This is the first method. I can still use another method to solve this. Now, the second method you can use to solve this is to know that when you have the logarithm of 3 to base of 27, that this can be seen as logarithm of 3. 27 is 3 power 3. There is a law of logarithm that is telling you that whenever the base is having a power, take the reciprocal of that base to multiply the logarithm. And the power of the base is 3. So the reciprocal of 3 will be 1 all over 3, then multiply by log 3 base 3. And there is a law of logarithm that is telling you that logarithm to its own base is equal to 1. So you have 1 over 3 multiplied by 1, which is equivalent to 1 over 3. You can see that these two methods I used gave the same answer. So let me use the third method also, still on one problem. Another method that can still solve this problem is what we call the change of base. Now, I have the logarithm of 3 to base 27, and I no longer like the base of 27 since it will be difficult to work on. These numbers, the simplest base I can use is 3, since 3 can factor all of them. 3 is a factor of all of them. So if I want the base to be 3, I'll just write logarithm to base 3 over logarithm to base 3. The first number here is 3, you write 3. The second number here is 27, you write 27. So you have log 3 base 3 over log 27 base 3. This is the same thing as logarithm to its own base is equal to 1 over, this is logarithm to base 3. 27 can be seen as 3 to the power of 3, because 3 to the power of 3 will give us 27. Then we now have 1 over, the power comes to the back, so you have 3 logarithm of 3 to base 3, and log 3 base 3 will give us 1, so we have 3 times 1, and 3 times 1 will give us 3. You see that the third method gave us the same answer, 1 over 3. You can see that logarithm has so many methods of solving it. Now let us still apply the same thing in the second problem to see if we are going to get a meaningful result. In the second problem, we have the logarithm of 25 to base of 125. So I can say let it be equal to x. So you have 125 to the power of x equal to 25. This is according to the relationship between indices and the logarithm. So 125 can be seen as 5 to the power of 3, because 5 times 5 times 5 in 3 places will give us 125. Then you still write your x equals 25 can be seen as 5 power 2, because 5 power 2 will give us 25. The bases are the same thing, automatically the powers are supposed to be the same thing, so you can equate the powers. You shall now have 3x is equivalent to 2, so to get x, divide both sides by 3, and when you do that, x is giving you 2 all over 3. Another way of doing this is to understand that when you have method 2, when you have logarithm of 25 to a base of 125, you should know that 25 can be seen as 5 power 2, and the 125 can be seen as 5 to the power of 3. Now, according to the laws of logarithm, the power will come to the back. So we have 2 logarithm of 5 to base 5 to the power of 3. Then again, when the base is having a power, you take the reciprocal of the power. And the reciprocal of 3 is 1 over 3. So you shall have 2 times 1 over 3 log 5 base 5. And 2 times 1 over 3 is 2 all over 3. Log 5 base 5 is the same thing as 1, because logarithm to its own base is 1. So 2 over 3 times 1 is still 2 over 3. You can see we are having the same answer. Then the last method that can still solve this problem is the change of base. So if you know any of this method you think is the best, you can always use them. They will give you the same answer. So let's apply change of base. Now when I see log 25 to base 125, I know that 5 is the simplest factor of all of them. So I have to change the base to 5 instead of using 125, which is big. So I'll just write logarithm to base 5 over logarithm to base 5. The first number is 25, while the second number is 125. Then 25 means 5 to the power of 2. So 5 to the power of 2 is 25. You write base 5 all over 125 is the same thing as 5 to the power of 3 base 5. From the laws of logarithm, the power comes to the back. So you shall have 2 log 5 base 5 all over, power comes to the back 3 log 5 base 5. If I like, I will say that logarithm of 5 to base 5 is 1 and logarithm of 5 to base 5 is also 1. Or this is logarithm to base 5 and this is logarithm to base 5. They cancel out, leaving you behind with 2 over 3. So you can see that you've got the same answer of 2 over 3. So you see that in this video I've preferred 3 solutions each to these questions. Thank you, and may God bless you for viewing.